So, throwback to algebra. I know you guys have seen this before because I taught Carnegie algebra curriculum before. It was way a few years ago, but I know you've seen it. So the process of deductive reasoning or deduction must have a starting point. So a conclusion based on deduction cannot be made unless there is an established assertion to work from. Right? That is so confusing. All it's saying is for us to figure something out, we need a starting point. So to provide a starting point for the process of deduction or figuring it out, a number of assertions are accepted as true without proof. So in the math world, we accept these things to be true because someone believed it a very long time ago. And so it's accepted to be true and we can use it in our daily math lives. So when you're solving an algebraic equation, you are using deduction. You are working your way through something, okay? You can use properties to support your reasoning without having to prove that the properties are true, okay? So example of our properties, addition property of equality. So if A is equal to B and C is equal to D, then I know A plus C is equal to B plus D. That's probably kind of confusing. So for example, let's say 2 is equal to 2 and 4 is equal to 4. Then 2 plus 4 has to be equal to 2 plus 4. That's all it's saying. They're the same thing on both sides. If I start off with 2 equals 2 and I add 4 to both sides, I use the addition property of equality. Okay, that's kind of what it's getting at. Subtraction property of equality is the same thing. If you use subtraction, multiplication property of equality, division property of equality, if you multiply to both sides, if you divide to both sides, those are the properties we're using. Distributive property, again, we've seen that in middle school a lot. Reflexive property is when you have the same on both sides. And so how I remember it is you flex here, you got flex here, so your muscles don't get off. Symmetric property is kind of like a mirror, symmetry. And so AB, BA. And then the transitive property is if A equals B and B equals C, then A equals C. So for example, if Tennessee Vols beat Florida and Florida beats Alabama, then Tennessee can beat Bama. And that obviously doesn't apply to sports. Okay. And then lastly, substitution property. We've learned substitution, replacing it for another value. Okay, so that's a review of your algebra terms. So let's solve some equations, okay? Move my face around. So I'm going to use one operation or property per step and solve this equation. So let's start it out. And this is probably not going to be great on the slate. So first off, I'm going to start right in the equation. So feel free to go ahead and do that with me. So 4x plus 9 equals 18 minus a half x, okay? So I can't combine the left side, I can't combine the right side, I have variables on both sides, I need to get my similar terms to the same side. So one way of solving this, I always like to get my variables to the left side. So I'm going to add a half to both sides, okay? So I'm left with 4.5. I'm going to go ahead and change it to 4.5. X plus 9 equals 18. So the reason I went from this first step to this second step was I added. So that's called the addition property of equality. Okay? So that'd be the addition prop of equality. Okay? The first thing, is my given equation, because it was given to me. Okay? All right, moving on. All right, so next up, I need to get my numbers or my constants to the other side by subtracting 9. So you would subtract 9, and you get 4.5x equals 9. So the reasoning right there, I subtracted 9 to both sides, so that would be the subtraction property of equality. And again, it's of equality because I'm doing it to both sides of my equation. All right, last but not least, I would divide by 4.5, and I would end up getting fun fact 2. So since I divided, again, the reasoning for that would be the division property of equality. Okay? I'm going to work on my handwriting on this little fun fact slate. Okay? But this would be an algebraic proof that you have used in your algebra class. Okay? And so we're going to get into geometry later on, but right now we're just kind of bringing back your memory of proofs. All right? So again, this is two-step column proof. You put the reasons on the right-hand side, you solve the equation on the left-hand side. So now it's time for y'all to try something. So you can organize the steps and the reasons used to justify the steps in 2 columns with statements called steps on the left and reasons, properties on the right. So this format is called a 2-column proof, and we will use this a ton in geometry, and you're gonna hate it, but we're gonna get through it. So here's an example A with my face. Given this equation, it wants you to prove that x is gonna be -3. Okay, so some things to realize, this given always goes first. Always, 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 okay? And the reason is always gonna be it's a given equation. They gave it to you. And then from there, you're going to work through the problem, solving the equation, but then you have to justify why you're doing it. So for example, from step 1 to step 2, I see this went away, right? That was the only thing that was different from here to here. So they probably added 1 to both sides, and that's why they got the addition property of equality. And that checks out because 11 plus 1 is 12. Then you have to ask yourself, well, from here to here, you know, what happened, what changed, this is the same, this is different. Well, hey, they distributed, okay? So what happens from here to here goes in this column, the distributive property, okay? Next step, what happened from step 3 to line 4? Well, the 6 stayed the same, the 12 stayed the same, the x's changed, so they moved the x's to the right-hand side, meaning that they subtracted 3x. Okay, since they subtracted 3x from both sides, you've got the subtraction property of equality. Again, the next line, from line 4 to line 5, the 2x stayed the same. This 12 disappeared on this side, so they probably subtracted 12, which means subtraction property of equality. Okay, from line 5 to line 6, they divided by 2, so division property of equality. And then last but not least, in the math world, we like to have x on the left-hand side. So they just flipped that thing around, which is a mirror image of each other. So that was a symmetric property of equality. Okay. So these are how 2-column proofs are working in algebra. Again, this is a review. You learned this last year. Just kind of refreshing your memory now. So finally, it is time for y'all to try some problems. So I want you guys to try this problem, A, all of A, and then part B. Again, this equation is familiar. We just kind of did it. Try and see if you can solve it a different way and prove it. But then we'll come back and talk about the answers. So press pause, and then we'll go over the answers. All right, so let's go over some answers. So on number 1, always the first thing is going to be a given equation. My dog is coughing. Pip. All right. On number 2, notice the only thing that was changed was they had parentheses and then a 10 on the outside. So they multiplied by the common denominator of a 10. And so since they multiplied, multiplication property of equality. From 2 to 3, this was pretty tricky. Notice that the numerator did not change, but the denominator did. And so they basically said, hey, 10 divided by 2 is 5. So they substituted that value in for 10, if that makes sense. You can also say simplified. They simplified because 10 divided by 5 is 2, or they substitute that property. That one was a little tricky. From 3 to 4, notice that the parentheses went away, which is kind of a giveaway for the distributive property. Last but not least, the 15 and the 12 stayed the same. This x disappeared, so it moved to the left-hand side by doing the opposite inverse operation, which is subtraction property of equality. Last but not least, they added 15, addition property of equality, and then they divided by 3 to get the division property of equality. Yes, you must have property of equality on half of those. Okay, you can abbreviate it POE if you want, but yes. All right, last but not least, I think I might have solved this the exact same way we did on the front page. Again, multiple answers to this. Just kidding, I did solve it differently. I subtracted 9 first and then added a half and then divided. But you can have lots of different answers for this one. Okay. It did want you to fix the proof part, and the proof part was, hey, I proved that x was a 2. Okay. So whatever you solve your equation to be, that will be the proof part. All right, let me know if you have any questions. Again, don't feel overwhelmed. We're definitely going to practice this. Proofs require lots of practice. All right, so to finish us out for the lesson, I want you guys to try 3 more problems, and then we are going to be done. So try 5, 6, 7, and then we'll go over the answers. So press pause, write down your answers, and we'll discuss. So here are some answers. So explain why undefined terms are necessary in geometry. So a few undefined terms are necessary so that all other vocabulary words can be defined based on those undefined terms. So basically, we need line, point, and plane so that we can create other definitions to learn in geometry. Number 6, what's the relationship between a conjecture, a theorem, and a 2-column proof? So this one was probably tricky. So you use a 2-column proof to prove that a conjecture is true. So a conjecture is a fancy word for a guess. Okay, you think it's true, but then you use a 2-column proof to prove it's true, and you know it's true. And then if it's proven true, it's a theorem. So let me say that once more. A conjecture is a guess. So you have some guess. You put it in a 2-column proof. You prove it's correct. It becomes a theorem, and then we know it's true. Okay. All right. Last but not least, on number 7, it wanted you to find his error and fix it. And so his error occurred between line 4 and line 5. He for some reason, multiplied to get 81 when he should have divided. And so to fix it, I wrote he should have used the division property of equality, should have divided by 9 to get -1. So the proof part should have been x equals -1, and then the reasoning should have been division property of equality. Okay? All right, so let me know if you have any questions on algebraic proofs and an introduction to geometry proofs. Again, this stuff is very challenging. You're going to learn it throughout the year. Don't freak out. But again, our learning targets were to distinguish between undefined terms and defined terms. So again, undefined terms are those basic things that we take as true: a point, a line, and a plane. Defined terms are geometric vocabulary words that we can create based on the undefined terms. And again, use properties to complete algebraic 2-column proofs, which is mainly what you're going to practice on next. So, to take us out of our lesson, I leave you with a math joke. Proofs are boring. That's a given. Get it? It's given. You write given on the proof. Proofs are boring. Proofs are boring. Sorry. Thank you for watching.